Super simple there. We have only one tool, which is the calorimeter. All right. So if you want to determine the enthalpy of reaction of the dissolving ammonium chloride in water, so to dissolve it, solid to aqueous. Yeah. So what's a heat change? Well, we just put this guy into water, to the calorimeter containing water, and look at the thermometer basically. Right. So ammonium chloride will absorb heat. That's why we use in the cold pack, which means that the temperature of water will be lower because it pulls energy from water, so it absorbs heat. So water gets cold. Okay. In this case, the reaction, which is the ammonium chloride, will gain heat plus, and the water will lose heat, become negative, minus. Right? And water is not water anymore. So this is really important. Water is not water anymore. Water becomes solution. So the mass right here going to be the mass of the compound and the water, the solvent combined, not just the mass of water, because it becomes the solution now. Okay. And the specific heat capacity is going to be that of solution. Unless it's too dilute, sometimes we still use the specific heat capacity of water still here. It doesn't change that much. Okay. And the other T, same thing, nothing different. All right, I'll do this one for you. 10.4 grams of ammonium chloride was combined with 100 grams of water in a coffee cup calorimeter, causing the water temperature to decrease by 6.2 degrees. So put these guys in, the temperature dropped by 6.2 degrees. Right? Based on this result, how much heat energy was required to dissolve the sample of ammonium chloride? Calculate the enthalpy of this solution of ammonium chloride in kilojoule per mole. So there are two questions. Find the heat transfer first, the heat transfer, and then calculate the heat, the enthalpy of this solution. The enthalpy. So here's the thing though. The heat transfer comes from the Q equal to ms delta T. That's a total heat. The enthalpy of the dissolution, enthalpy is a heat per mole, the kilojoule per mole. See that? So whatever you have heat right here from Q ms delta T divided by moles of ammonium chloride, you get to the enthalpy of the dissolution. Okay, I'll show you. If you don't get what I say, I'll show you. Okay, all right. So watch out though. So the solution, not water anymore. This is a solution. The temperature of the solution dropped by 6.2, decreased by 6.2. So the delta T of the solution is negative because water is losing heat. Right? Water release heat, so the temperature drops. Okay. One gains heat, one loses heat. And that solution loses heat. So the reaction ammonium chloride gains heat. All right. So Q of solution equal to ms delta T. Everything is for solution. And that all of them are for solution. All right. And now just plug in mass of the solution. So this is a mass of water and the ammonium chloride combined. So it's just not 100 grams anymore. It's 100 plus 10.4. All right. So watch out that the specific heat of solution, we still use the specific heat of water because we assume that the solution is still dilute. So it's still the property of water doesn't change as much. So just keep 4.184. That's for water. And delta T is negative 6.20 degrees Celsius. Gram cancel out, Celsius cancel out. Now do the math there, you get that number. Negative cancel out too. Okay, and make a 1, 2, 3. So 3. So move the decimal 10 to the third. That's kilojoule. And round it down. Get that. Okay. All right, not done yet. So that's the first question. So based on this, how much heat energy was required to dissolve the sample of ammonium chloride? So the heat that the whole ammonium chloride, 10.4 grams of ammonium chloride absorbed is that number in kilojoule. Now we have to calculate the enthalpy of the dissolution of ammonium chloride in kilojoule per mole. So per mole. This is per 10.4 grams. See that? This number is per 10.4 grams. We want to find kilojoule per mole. Well, convert unit to unit basically. Kilojoule to kilojoule was already the kilojoule, and grams to mole. Okay. So all right, grams to mole. Since grams is at the bottom, I'm gonna put grams at the top and moles at the bottom. You know. And grams of ammonium chloride. So what's it? What's the rate? Oh, 1 mole ammonium chloride is 53.5 grams. That's the molecular weight. Okay. Grams cancel with grams. You get kilojoule per mole. Do the math there. You get that number. What sig fix there? 3 sig fix. 3 sig fix. Good. 3 sig fix. There we go. All right. So note that when I plug in here, I use 2.86386432 kilojoule. I didn't use the one that I route off. All right. So again, one more time. Every time when you route off, you add the uncertainty to your calculation. All right. So when you want to route off, do it only one time. If you need this number to do something else, use the one that you haven't routed off yet. Put in here. Okay. So keep the uncertainty the same. All right. Now your turn. So try to do this together on the next video.